Hi all, my name is Fahim. So today I'll be talking about operating systems. So I have already been doing this study of operating systems for a few weeks now. So I'm going to continue with the operating systems. And today I'll be discussing about operating system structure and also computer system architecture. These are the two things that I will be discussing today. So first let's talk about operating system structure. So operating systems are different, right? So let's look at the operating systems that we all know. So Windows, Mac OS and Linux. These are the main big things that we know about. But even though they are very different, they have a lot of commonalities, right? And these things are what make an operating system. So if these operating systems didn't have these features, then they would not be an operating system. So I'll be talking about two of the commonalities, that is multi-programming and time scheduling or multitasking. So let's talk about multi-programming. And multi-programming is when the CPU is able to do multiple stuff at the same time. I mean, not at the same time, but that it is able to um, stop one process and then do something else at the between any delay there is. So I'll explain that. I know you didn't understand anything. So let's say that the user is doing something, and in between this process, this program has to talk with the device driver. All right. So that means the CPU is not actually doing anything during that time. The CPU is free. So if multi-programming was not a thing, then this CPU would just be sitting there and it's just idle, not doing anything. But with operating systems that have multi-programming, this CPU will be able to do other tasks in between this time when the program is talking to a device driver, right? So that is sorry. So that is multi-programming. So next, let's talk about time scheduling or multitasking. So this is what allows many users to make use of the system at the same time. So this is possible because at the same time many users can use the same system because the system is very fast, right? Comparatively to the human beings who take much longer compared to how long it takes for a system to do something. So let's say between the keystrokes, it might look like, even if you're a fast typist, it might look like you're typing really fast, but for the system there is a lot of time in between you touching one key and then the next key. So between that time the system can do a lot of other things than waiting for you to complete your typing. So this is exactly what allows for multiple users to use the same computer. So in between the time that it takes for a user to do something, the computer can work out what the other user is doing at the same time. So to us it might look like we are just the only one person using the computer, but actually we wouldn't know that other people are using our, if it is a shared computer, we wouldn't feel like other people are using our computer because it's so damn fast, right? So these are the two main things that operating systems must have, right? So that was the operating system structure. So now let's talk about computer system architecture, and I'll be talking about the different types of GPUs, I mean systems based on the number of general purpose processors or GPUs. So um, there are three types, that is single processor systems, multi-processor systems, and also we have cluster systems. All right. I'm looking at my notes here, so just to refer. So single processor systems have one main CPU that does all of the general stuff, and they also have other special purpose processors that maybe for specialized tasks like device specific tasks and stuff like that. So this is a single processor system. It's called a single processor system, but it doesn't actually have just one single processor, right? I said it has one main CPU that is um, that does all of the general tasks, and then it has specialized processors also. So it doesn't actually have just one processor, it has one general purpose processor, that is the processor that does general things, right? So that's why it's called a single processor system. And then next we have a multi-processor sorry next we have a multi-processor system. So in this we actually do have multiple general purpose CPUs. Alright, and this is good because it is more reliable. So if one of the processors fails, then other processors are still there, so they can manage, even though the speed might be a bit less, it can still work things out. It won't break like the other one. In a single processor system, if the general purpose processor has an error or errors out, then the whole system is done for, because there's no other thing that can manage these things. So in a multiple processor system, we don't have to worry about that, so it's much more reliable. All right, and we have two types of multiprocessor systems. One is symmetric and the other is asymmetric. In symmetric, all of the processors are equal and they share all of their tasks and work accordingly. That's symmetric. But in asymmetric, there is one processor that is the master. It's a master slave relationship in which there is a master at top and all of the other processors are the slaves. And this master assigns the tasks to each of these processors. So this is good because there's a lot of system to it, and the master is able to assign tasks to each one. But the problem is that the master is not really doing anything in this type of system. That is the only drawback. Okay, so the last one that I have to talk about is cluster systems. So these are like multi-processor systems, but which have multiple processors, right? But in this clustered system, it's not multiple processors that we have multiple systems. That is multiple systems with everything, not just the processors. It has all of the device drivers and all of those stuff. So it's like you have a bunch of computers. That's basically what a clustered system is, and it all works together. And so that means there's a lot of high availability, and since it is a multiple systems and not just processors, it can do much more. It's more powerful. And in this also we have symmetric and asymmetric uh, type of cluster systems. And obviously symmetric ones are much better, because in asymmetric, one of the system will not be doing anything, it will just be scheduling tasks for other processors. So I talked about, that's all from me, so I'll just recap a bit. So I talked about the commonalities that are present in all operating systems, that have to be present in all operating systems, and I also talked about different types of systems based on the number of general purpose processors. So that's all from me. Thank you.